Here's something that shouldn't work. A magnetic field thousands of times weaker than the little magnet holding a note to your fridge reaches into a living cell and changes how much energy that cell produces. That's the headline from a new 2025 study on mitochondria, the tiny structures that act as the powerhouses of nearly every cell in your body. A team led by Gisela Beutner and Sheu took mitochondria from rat hearts and exposed them to a very weak, steady magnetic field. And what they saw was striking. In a narrow window of field strength, the mitochondria ramped up their energy production by as much as 40%. And at the same time, they cut back on the harmful corrosive byproducts that normally come with respiration. More energy, less damage from a magnetic whisper. But here's the strange part. The cellular environment is supposed to be far too inhospitable for meaningful, non-trivial quantum states to partake in biochemistry. You see, a field as weak as that in Beutner and Sheu's study carries almost no energy. Far, far less than the ordinary heat jostling every molecule in the cell. By the old rules of chemistry, its effect should be completely drowned out, like trying to hear a pin drop over a jet engine. So how does it work? The leading explanation comes from quantum spin chemistry. It's called the radical pair mechanism, and it's the same physics thought to let migrating birds navigate by the Earth's magnetic field. The idea is this. Some reactions pass through a fleeting moment where two electrons on two molecules have their spins linked. Those spins can flip between two arrangements, and each arrangement sends the reaction down a different path. A weak magnetic field doesn't need to force anything, it just nudges that quantum coin flip, and the chemistry amplifies the rest. Now, this isn't the first time magnetism has been linked to cellular energy. There's a long and frankly contested backstory here, including bold earlier claims about magnetic magnesium isotopes that were shown to double ATP synthesis. However, to this day, these results have not been independently reproduced. I will discuss this more in the associated article. So a little caution is healthy, but what makes the Beutner result compelling is how carefully it was done and how well it lines up with something we've covered before on this channel. A 2026 study showing that these same magnetic and isotope effects shape the assembly of microtubules, the scaffolding of the cell. Two very different systems, the same underlying quantum physics. At the ISF, that's the thread we find most interesting. Not one enzyme reacting in isolation, but a whole cell full of spin-active machinery, all potentially tuned by the same subtle field. We're only beginning to understand what that means, but it's a beautiful reminder that the gap between what we can measure and what we can explain is exactly where the best science lives. I'll drop the full article and the references below. Thanks for watching, and stay curious.